Does it ever blow your mind that we can transfer heat from a cold space to a hot space? I had a hard time wrapping my head around that. And, my dad tried to explain that to me time and time again. I know I've mentioned this in previous videos, and I didn't absorb what he was telling me how it worked until I took my first class in thermodynamics. So I think it's probably worthwhile just to talk a little bit about transferring heat from cold to hot. Now, you know this is possible, right? Is it possible to buy and run a refrigerator? We talked about this previously. Of course it is. You depend on refrigerators, so you know very well that that's possible. And of course you say, but heat only flows from hot to cold on its own. Everybody knows that. Well, the trick is that it takes some amount of work or power to accomplish the task. And the second law says that there was one of those statements of the second law stated just that heat doesn't flow from cold to hot on its own. And it just stops there, right? You can't operate in a cycle and heat flowing from cold to hot. It only flows from hot to cold on its own. So you do recognize in the real world, it takes some amount of work or power to accomplish the task. And so, again, I want to simply reinforce, and thank goodness on my schematic, I reinforced the importance of drawing schematics. So what is a refrigeration cycle? In other words, transferring cold to hot. How do you draw a schematic of that? Okay. It looks very similar, right, to the power plant, but what's different? What's different is that our heat is flowing out of the cold space into the system operating in a cycle, and then it's being discharged up to a high temperature reservoir, which typically for a refrigerator is the surroundings, right? So we're going from the cold space or freezer section down here, low temperature reservoir, up to the surroundings, the higher temperature reservoir. And you realize in the real world, it takes some power to accomplish this. And the neat thing is, in a subsequent chapter, you're going to really learn the details of how to do the computations for this type of refrigeration cycle. So we observe that this is possible. Okay, so let's just go with, it says practice with first law and thermal efficiency. That's also going to be another typo. This has nothing to do with thermal efficiency, because thermal efficiency has nothing to do with the refrigeration cycle. But let's look at the schematic. And if you're given, let's say you got a quiz and you've got Q dot H is 8 units and Q dot L is 3 units. Let's see, what would it take? Without even looking at the formula that you see over there for the first law, Q dot H minus Q dot L is W dot net. Without even looking at the formula, if you're familiar with drawing the schematic, you say, wow, I've got 8 going out and I've got 3 going in. And so what do I need to make up? What kind of ingoing energy do I need to make up to get the 8 going out? 5. And so with my eyes, I can see that W net is simply 5 units. And so that's really not bad, despite my, again, copy and paste carelessness with putting thermal efficiency on there. So that gets you up to speed on transferring heat from cold to hot. So transferring heat from cold to hot is certainly possible. We observe it with a refrigerator or an air conditioner. And so what I want you to get familiar with is the concept of a low temperature reservoir, the cold space, and a high temperature reservoir, typically the surroundings. That's important. And so this short video, I hope, gets you familiar and comfortable with drawing a schematic of this sort of the opposite of a heat engine. So do you see that the schematic for a refrigeration cycle, it's the same for a heat pump cycle. It's sort of the opposite of drawing the schematic for a heat engine. So that's it. In the next video, we're going to talk about quantifying the performance of a refrigerator. And it's going to be different, and it is not going to be thermal efficiency. going to be a different definition. We call it coefficient of performance, and we'll talk about the ins and outs of that in the next video.